an apple falls from a tree. But what if that simple moment unlocked the secrets of the universe? Behind candlelit studies, glowing prisms, and mysterious alchemical chambers, one man reshaped the way we see reality. From the royal mint to the royal society, from the rainbow hidden in a beam of light to the equations etched into the stars. This is the story of Isaac Newton, a genius whose discoveries were as brilliant as they were mysterious. Gottfried Wilhelm Leibniz, 1646 to 1716, and Isaac Newton, 1642 to 1727, stand as two of the most towering intellectual figures of the 17th century, men whose parallel pursuits in mathematics, philosophy, and natural science exemplify both the collaborative and contentious spirit of the scientific revolution. Leibniz, a German polymath with an insatiable curiosity that spanned law, theology, logic, metaphysics, mechanics, and diplomacy, embodied the ideal of the universal thinker, while Newton, the English mathematician and natural philosopher, pursued with unmatched intensity the laws that govern the universe. Although separated by geography, upbringing, and temperament, both men confronted similar intellectual problems and often, without direct communication, devised solutions that would come to define modern science. Nowhere is this more famously illustrated than in the independent discovery and development of calculus, the mathematical tool that revolutionized the ability of scientists to describe motion, change, and the infinitesimal. Newton claimed to have devised his method of fluxions in the mid-1660s during his Annus Mirabilis, a period of extraordinary creativity in which he also developed the foundations of optics and gravitation, though he delayed publication for decades. Leibniz, working later but publishing sooner, introduced his differential and integral calculus in the 1680s, using a notation, dx, dy, tires, that proved vastly more practical and enduring than Newton's own symbols. The result was a bitter dispute over priority, fueled not only by national rivalries between England and continental Europe, but also by the personal pride of two men unwilling to yield intellectual ground. Yet, viewed with historical distance, the quarrel reveals less about who invented calculus first and more about the nature of scientific progress itself. Knowledge builds cumulatively, and when the conceptual groundwork has been laid by predecessors like Galileo, who analyzed accelerated motion, and Kepler, who mathematically described planetary orbits, it is almost inevitable that multiple brilliant minds, exposed to the same intellectual currents, will converge upon similar insights. This phenomenon, sometimes called multiple discovery, underscores that ideas often have a momentum of their own, ripening within the collective thought of an era until several individuals are capable of articulating them. Thus, rather than diminishing the stature of either Newton or Leibniz, the dual invention of calculus magnifies their significance, for it demonstrates not only their genius, but also their role as representatives of a transformative epoch in which mathematics became the universal language of nature. Their rivalry, however, extended beyond the technicalities of calculus into broader philosophical and metaphysical domains. Newton, deeply influenced by his theological convictions, conceived of a universe whose order and stability were maintained by divine intervention, particularly in the regulation of planetary orbits. Leibniz, conversely, envisioned a rationally ordered cosmos governed by pre-established harmony, in which God's perfection obviated the need for continual adjustments. Their correspondence, often sharp and polemical, reflected two distinct worldviews. One empirical, experimental, and at times secretive, the other speculative, systematic, and boldly metaphysical. Yet both approaches contributed indispensably to the shaping of modern thought. Newton's calculus became inseparable from his mechanics, enabling precise predictions of celestial and terrestrial motion, while Leibniz's notation and philosophical reflections on infinitesimals opened pathways not only in mathematics, but in logic and computer science centuries later. Moreover, the controversy over calculus priority spurred institutions like the Royal Society in London and the academies of Paris and Berlin to assert national intellectual prestige, thereby accelerating the professionalization of science. In hindsight, the dispute can be seen as a catalyst that forced the scientific community to grapple with issues of authorship, publication, and recognition that remain central to research culture today. Thus, the connection between Leibniz and Newton is not simply a story of rivalry, but of complementarity. Newton provided the physical theories that required new mathematics, while Leibniz supplied the mathematical language that allowed generations of scientists to apply those theories with elegance and efficiency. Together, though unwilling collaborators, they exemplify the dual engines of scientific progress: intuition about nature's workings and the symbolic systems needed to express that intuition precisely. Their lives, works, and conflicts illuminate the complex interplay between genius, context, and tradition in the creation of knowledge, reminding us that great ideas rarely emerge in isolation, but rather at the crossroads of shared heritage and individual brilliance. Isaac Newton's publication of the Philosophia Naturalis Principia Mathematica in 1687 did not occur in an intellectual vacuum, but rather against the backdrop of intense political, religious, and social turmoil in late 17th century England, a time when questions of sovereignty, legitimacy, and the future of the monarchy were debated as fiercely as those of science and philosophy. When Newton presented his masterpiece to the world, King James II was on the throne, a monarch whose Catholic sympathies and attempts to expand royal power aroused widespread suspicion among the Protestant political class. Within a year, England would undergo the Glorious Revolution of 1688, a relatively bloodless upheaval that deposed James and installed the Protestant William of Orange and his wife Mary as co-sovereigns. The timing of the Principia's appearance in this politically charged atmosphere is significant. While the book itself was a work of pure natural philosophy, laying down with unprecedented rigor the laws of motion and the universal law of gravitation, its intellectual message about an ordered and lawful cosmos resonated in a society struggling with questions of order, authority, and governance. Newton himself, however, was not at this stage deeply engaged in political affairs. By temperament, he was reclusive, absorbed in study, and often reluctant even to publish his discoveries. Nevertheless, the prestige conferred by the Principia gradually drew him into the orbit of public life, and over the next decades, he would transition from the cloisters of Cambridge to the very heart of the English state. Initially, Newton's political involvement was limited. He briefly represented Cambridge University in Parliament in the 1689-1690 session, and though he was not a prominent orator, famously it is said he spoke only once to request that a window be closed. His very presence testified to the growing recognition of science in public affairs. More substantial engagements came later, when Newton's reputation as the greatest natural philosopher of his age combined with his connections to powerful patrons to secure him positions of influence. By the mid-1690s, Newton's health was fragile and his appetite for academic disputes at Cambridge diminished, yet he was increasingly drawn into circles of political and economic reform. In 1696, he accepted the post of Warden of the Royal Mint, a decision that would alter the trajectory of his life and place him at the intersection of science, politics, and finance. The office of the Mint, and particularly the crisis facing England's currency at the time, provided Newton with an opportunity to apply his analytical genius to practical matters of statecraft. England's coinage system had become chaotic. Widespread clipping and counterfeiting of silver coins had undermined confidence in money, leading to inflation, hoarding, and disruptions in commerce. The so-called Great Recoinage was an ambitious plan to recall, remint, and standardize the nation's silver currency, a task fraught with the logistical, economic, and political challenges. As warden, and later as master of the mint, a position he assumed in 1699, Newton undertook this responsibility with a combination of scientific rigor and administrative discipline. He introduced meticulous assays of coinage, enforced strict standards of weight and purity, and pursued counterfeiters with unrelenting vigor, personally attending trials and employing methods of detection that revealed both his experimental skill and his uncompromising sense of justice. In this role, Newton became not only a guardian of England's monetary stability, but also a symbol of how scientific methods could be harnessed for the governance of society. His reforms helped restore public trust in the currency, facilitated the expansion of trade, and indirectly contributed to England's rise as a global financial power in the 18th century. Newton's tenure at the Mint also illustrates the complexity of his character. Though often portrayed as a solitary genius, in this context he functioned as an efficient bureaucrat and political actor, navigating alliances, asserting authority, and shaping policy. His ability to transition from the abstract realms of celestial mechanics to the practical concerns of economics and governance underscores the breadth of his talents and the versatility of the scientific mindset in an age of transformation. Moreover, his service at the Mint linked him to the broader ideological struggles of his time. The Glorious Revolution had established a constitutional monarchy in which Parliament gained new powers, and the stability of the state increasingly depended on reliable financial institutions. By safeguarding the integrity of coinage, Newton was in effect buttressing the credibility of the regime of William and Mary and the nascent fiscal military state that would finance England's wars and imperial expansion. Beyond the Mint, Newton's political and administrative engagements extended into other arenas. He served as president of the Royal Society from 1703 until his death in 1727, a position that gave him influence not only over the direction of scientific inquiry, but also over the cultural prestige of science within the polity. Under his leadership, the Royal Society grew in prominence, attracting patronage and symbolizing the alignment of scientific advancement with national greatness. Newton's authority was further cemented by his knighthood in 1705, conferred by Queen Anne, which elevated him into the ranks of the political elite and marked one of the earliest recognitions of a scientist with such an honor. Though never a politician in the conventional sense, Newton's career thus embodied the gradual integration of scientific expertise into the machinery of the state. The political context of Newton's later life also colored the reception of his Principia. The work's insistence on universal laws governing both terrestrial and celestial bodies offered a vision of order that mirrored, and perhaps subtly reinforced, the search for political stability after decades of civil war, religious strife, and dynastic upheaval. Some contemporaries interpreted Newton's cosmos as reflecting the rational providence of God, whose invisible hand sustained both nature and society, while others saw in his mathematical rigor a model for rational governance. Newton himself, cautious about metaphysical speculation in his published works, nonetheless engaged in theological debates privately, and his personal unorthodoxies, his rejection of the Trinity, his fascination with prophecy, his meticulous study of biblical chronology, remained concealed from the public eye. Yet even these pursuits testify to the ways in which Newton's scientific vision was intertwined with broader concerns about order, morality, and authority in a world still negotiating the legacies of Reformation and Revolution. In sum, the period beginning with the publication of the Principia Mathematica and culminating in Newton's stewardship of the Mint illustrates the multifaceted character of his genius and the interpenetration of science and politics in early modern England. Far from retreating into ivory tower abstraction, Newton's life after 1687 demonstrates how intellectual authority could be mobilized in service of the state, how scientific methods could resolve practical crises, and how a man once reluctant to publish his findings became a central figure in the consolidation of both scientific and political order. His reform of England's coinage system was not a mere technical achievement, but part of a larger process by which knowledge, power, and trust were renegotiated in the aftermath of revolution. Thus, Newton the natural philosopher and Newton the public servant cannot be separated. Together, they form the portrait of a thinker whose impact extended from the motions of planets to the stability of nations, and whose legacy rests not only in the Principia, but also in the durable institutions he helped to shape. Isaac Newton's scientific career entered a new and highly influential phase in 1703, when, following the death of Robert Hooke, he was elected president of the Royal Society, the premier scientific institution in England and arguably in Europe. This position not only gave him formal authority over one of the most important organizations of scientific exchange, but also allowed him to shape the intellectual agenda of natural philosophy at a moment when experimental science was becoming institutionalized and professionalized. Newton brought to the presidency not only his formidable reputation as the author of the Principia Mathematica, but also his characteristic determination, organizational ability, and, admittedly, his personal ambition, which meant that he was not merely a passive figurehead, but an active shaper of the Royal Society's trajectory. Under his leadership, the Society's finances were stabilized, its membership broadened, and its publications, particularly the philosophical transactions, grew in stature, ensuring that England remained at the center of scientific communication in an era when networks of knowledge were becoming increasingly international. Newton's presidency also provided him with an institutional platform from which to defend his own theories, promote his allies, and marginalize his rivals, thus intertwining the advancement of science with the complex dynamics of reputation, authority, and power. It was in this context that Newton published Optics in 1704, a work that, although long in gestation, represented his most mature reflections on the nature of light, color, and vision. Unlike the dense, geometric style of the Principia, Optics was written in a clearer and more accessible form, employing experiments and queries to guide readers into the intricacies of refraction, diffraction, and the spectrum of colors. The book built upon Newton's earlier studies, dating back to the 1660s, in which he had used prisms to demonstrate that white light was not simple and homogeneous, as many had supposed it, but instead composed of rays of differing refrangibility, each associated with a distinct color. By systematically refracting light through prisms and lenses, Newton had shown that colors were not modifications of a single underlying substance, but fundamental components of light itself, a conclusion that overturned centuries of Aristotelian and Cartesian assumptions. In Optics, he extended these ideas, elaborating on phenomena such as the rings of color seen in thin films, now known as Newton's rings, and offering speculations on the corpuscular nature of light, which he believed to consist of small particles emitted by luminous bodies. Although the wave theory of light, championed by Christian Huygens, would later resurface and ultimately triumph in the 19th century, Newton's corpuscular theory held sway for much of the 18th century, illustrating the immense authority he wielded as both a scientist and a leader of the scientific community. Yet Newton's later scientific career was not characterized solely by triumph and innovation. It was equally marked by jealousy, rivalry, and the darker aspects of his personality. His disputes with Robert Hooke had already demonstrated his sensitivity to criticism and his tendency to guard his priority claims with ferocity. After Hooke's death, Newton faced new conflicts, the most notable of which involved John Flamsteed, the first astronomer royal. Flamsteed had devoted decades to meticulously charting the stars, compiling data that would be essential for improving navigation and for testing Newton's gravitational theories. However, Newton's impatience with Flamsteed's slow pace and his insistence on controlling the dissemination of Flamsteed's data led to an acrimonious quarrel. As president of the Royal Society, and later as a powerful figure in government, Newton used his influence to pressure Flamsteed into releasing his star catalog before he considered it ready for publication. This culminated in the 1712 unauthorized printing of Flamsteed's Historia Coelestis, overseen by Newton and his ally Edmund Halley. Flamsteed, outraged, fought back vigorously, eventually regaining and burning many of the printed copies, an act that symbolized his determination to protect both the integrity of his work and his scientific reputation against what he saw as Newton's high-handed interference. The conflict between Newton and Flamsteed reveals not only Newton's domineering nature, but also the broader struggles within early modern science over data ownership, intellectual authority, and the rights of individual investigators versus the demands of institutional and theoretical agendas. Nevertheless, Newton's collaboration with Edmund Halley, though complicated, also illustrates his capacity to form fruitful alliances. Halley, a brilliant astronomer and mathematician in his own right, had played a crucial role in encouraging Newton to publish the Principia decades earlier, even financing its printing when the Royal Society's coffers were depleted. Their relationship was occasionally strained, particularly during the Flamsteed affair, when Halley's loyalty to Newton placed him at odds with Flamsteed, but it also demonstrates how Newton could inspire and mobilize others around his intellectual vision. Together, Newton and Halley advanced the study of comets, with Newton's gravitational theories providing a framework for Halley to predict the return of the comet that would bear his name. This blending of Newton's theoretical genius with Halley's observational and organizational skill exemplified the collaborative dimension of science, even when overshadowed by Newton's personal rivalries. The publication of Optics in Newton's presidency of the Royal Society cemented his dominance over 18th century science. Optics not only influenced experimental physics, but also inspired philosophical reflection, with its famous queries at the end of the book posing bold, speculative questions about the nature of matter, force, and the role of God in the universe. These queries, written in an open-ended style, invited readers to consider possibilities beyond the strict results of experiments, thereby bridging the gap between empirical investigation and metaphysical speculation. In this way, Newton's work straddled the line between strict natural philosophy and a more expansive vision of knowledge, where physics, theology, and philosophy intersected. The Optics was rapidly translated into other languages and became a central text in the Enlightenment, shaping the way thinkers across Europe approached the relationship between experiment, theory, and speculation. At the same time, Newton's jealousies and rivalries cast long shadows over his later career. His harsh treatment of Flamsteed is often cited as one of the most glaring examples of his authoritarian tendencies, but it was by no means unique. Newton was deeply concerned with securing his legacy and defending his intellectual property, often interpreting disagreement as personal hostility. He meticulously curated his correspondence and publications, sometimes rewriting history to emphasize his priority in discovery, as seen in the long-standing dispute with Leibniz over calculus. The Flamsteed affair fits into this larger pattern, illustrating Newton's desire to dominate the narrative of scientific progress and to subordinate others to his vision. For Newton, science was not only a matter of uncovering truth, but also of asserting authority, a combination that both advanced his reputation and engendered lasting resentment among those who crossed him. In sum, Newton's scientific career after 1703 was a mixture of extraordinary achievement and personal conflict. As president of the Royal Society, he consolidated his authority and institutionalized his vision of science. Through the publication of Optics, he advanced a revolutionary understanding of light and color that would shape physics for generations. And in his collaborations with figures like Edmund Halley, he contributed to the flowering of astronomy. Yet, these accomplishments were accompanied by rivalries and disputes, particularly with John Flamsteed, that exposed the more human and sometimes less admirable dimensions of his character. Newton's legacy from this period is thus double-edged. He was both a pioneer who expanded the frontiers of knowledge and a jealous guardian of his own reputation, both a leader who strengthened the scientific community and an autocrat who could undermine the very spirit of cooperation that science requires. The richness of this legacy lies precisely in its complexity, for it reminds us that scientific greatness is not merely a matter of intellect, but also of personality, power, and the intricate dynamics of human ambition. In the later stages of his long and remarkable life, Sir Isaac Newton increasingly found himself at the intersection of science, government, religion, and the esoteric traditions of alchemy, embodying the complexities of a 17th and early 18th century thinker who could not be confined within the categories of modern specialization. After decades devoted to the advancement of mathematics, physics, and natural philosophy, Newton in his maturity did not withdraw into private contemplation, but rather embraced responsibilities in public service, most notably through his leadership roles in the English Mint, Parliament, and eventually the Royal Society, while continuing, often in secrecy, his explorations into theological interpretation and alchemical speculation. His appointment as Master of the Mint in 1696, a position of immense practical importance, had already demonstrated his capacity to translate the rigor of scientific reasoning into the concrete problems of economic stability and national governance, as he led a sweeping recoinage that curbed widespread counterfeiting and stabilized the English currency. But even as he carried out such worldly duties, Newton never entirely abandoned the intellectual passions that had defined his earlier career. Alongside the celebrated mathematical and physical investigations that had culminated in the publication of his Philosophia Naturalis Principia Mathematica in 1687, a work that provided the definitive formulation of the laws of motion and the universal law of gravitation, Newton pursued parallel inquiries into the hidden structure of reality, believing that the truths of the natural world could not be fully understood without recourse to divine design and ancient wisdom traditions. His voluminous manuscripts on biblical chronology, prophecy, and the interpretation of sacred scripture reveal a mind convinced that history itself was governed by mathematical patterns and divine providence, while his vast alchemical notebooks, filled with experiments, allegorical readings, and coded passages, show his conviction that matter concealed transformative powers accessible only to the adept who could decipher nature's secrets. Though much of this work remained unpublished during his lifetime, either because he feared the disapproval of contemporaries or because he regarded such studies as too dangerous or sacred for the vulgar eye, later generations, upon uncovering these texts, would come to appreciate the breadth of Newton's intellectual horizon. He was not merely a physicist in the modern sense, but a seeker of ultimate knowledge in all its forms, convinced that God's creation was a unified whole awaiting discovery through patient inquiry. Meanwhile, his Principia continued to shape the trajectory of science long after its initial publication, hailed by his contemporaries and successors alike as a cornerstone of modern thought, a book that did for natural philosophy what Euclid's Elements had done for geometry. Its synthesis of terrestrial mechanics and celestial motion under a single mathematical law represented a triumph of human reason, demonstrating that the same force that caused an apple to fall also held the planets in their orbits. This vision of a universe governed by universal laws inspired generations of scientists, philosophers, and even political thinkers who drew analogies between Newton's orderly cosmos and the possibility of rational order in human society. Yet Newton himself, though celebrated as the greatest natural philosopher of his age, did not see the Principia as the final word. He revised the text across multiple editions, refining arguments, responding to critics, and extending proofs, while privately continuing to wrestle with unresolved questions about the nature of space, time, and divine action. His reluctance to accept certain mechanistic interpretations, his insistence on God's active role in maintaining cosmic stability, and his openness to mysteries that lay beyond the reach of mathematics remind us that Newton was both a revolutionary and a traditionalist, straddling the boundary between medieval conceptions of divine order and modern scientific empiricism. As the years passed, Newton's stature only grew. In 1703, he became president of the Royal Society, a position he would hold until his death in 1727, consolidating his influence over the scientific community of England and, by extension, Europe. Under his leadership, the Royal Society gained prestige, financial stability, and international recognition, becoming a central institution for the exchange of scientific ideas and discoveries. His publication of Optics in 1704, though focusing on research he had conducted decades earlier, reaffirmed his intellectual dominance by providing a comprehensive account of light, color, and the nature of vision. And its queries opened paths of inquiry that would occupy physicists for centuries. Yet Newton's later life was not free of controversy, for his reputation for jealousy and rivalry persisted, most famously in his disputes with the astronomer royal, John Flamsteed, and with continental figures such as Gottfried Wilhelm Leibniz, whose priority dispute with Newton over the invention of calculus became one of the most bitter and public feuds in the history of science. These conflicts reveal not only Newton's human frailties, but also the high stakes of intellectual life in an era when scientific discovery was rapidly reshaping the understanding of the world and conferring unprecedented cultural authority upon its practitioners. Despite these quarrels, Newton's legacy by the end of his life was secure, and his death in 1727 was marked by honors befitting a national hero, including burial in Westminster Abbey, an extraordinary recognition for a scientist in an age when such memorials were typically reserved for monarchs and great statesmen. Yet, as later centuries would reveal, the true scope of his thought was far wider than the polished public image presented in his lifetime. With the posthumous publication and study of his theological and alchemical writings, scholars came to realize that Newton was not merely the rational mechanist of Enlightenment myth, but a thinker deeply engaged with questions of God, prophecy, and the transmutation of matter, reflecting the persistent entanglement of science, religion, and mysticism in early modern Europe. Far from diminishing his scientific achievements, this broader understanding enriches our appreciation of Newton as a figure who sought to unify all knowledge under the banner of divine truth. The Principia, though revised and refined by later thinkers, retained its place as a foundational text, providing the conceptual framework within which 18th and 19th century science operated. Even when Albert Einstein, in the early 20th century, introduced the theories of relativity that replaced Newton's notions of absolute space and time with a more dynamic conception of space-time curvature, he did so with profound respect, acknowledging that Newton's vision remained a magnificent approximation of reality, valid within the domain of ordinary experience. In this sense, Newton's work was not overturned but extended, demonstrating that even the most revolutionary insights are stepping stones in the ongoing pursuit of truth. His commitment to meticulous observation, mathematical clarity, and the search for underlying principles continues to inspire scientific inquiry, while his integration of natural philosophy with broader cultural and theological concerns reminds us that the boundaries between disciplines are historically contingent and intellectually porous. Newton's later years, with their blend of public service, private speculation, and scientific refinement, thus encapsulate the paradox of genius. A man at once intensely practical and profoundly mystical, fiercely competitive yet deeply pious, a servant of the state and a seeker of ultimate wisdom. To study Newton in his later life is to glimpse not only the consolidation of modern science, but also the enduring human desire to find unity amidst the diversity of knowledge, to reconcile the visible with the invisible, and to discern in the fabric of the cosmos the signature of the divine. Isaac Newton's legacy is immense, a towering monument in the history of human thought that seems at once luminous in its clarity and shrouded in darkness, a paradoxical inheritance that continues to haunt the corridors of science and philosophy even centuries after his death. For though he is celebrated as the discoverer of gravity, the architect of calculus, and the master of optics, his life and mind conceal chambers of secrecy, obsession, and enigma that resist easy comprehension, suggesting that the man who revealed the clockwork of the cosmos was himself a labyrinth as intricate as the universe he sought to explain. And to begin to understand Newton is to wander into a world where reason and mystery entwine so tightly that they can scarcely be untangled, where the shining brilliance of mathematics is illuminated by the flickering shadows of prophecy and alchemy, where the apple that falls is not merely a fruit, but a symbol of hidden forces binding heaven and earth, and where every prism that fractures light into color seems to hint at concealed dimensions of reality. His discovery that the same force pulling an apple toward the ground also governs the moon's orbit around Earth and the planet's majestic dance about the sun was not merely a scientific revelation, but an unveiling of something deeper, as though Newton had brushed against the secret threads of creation itself, perceiving an invisible architecture woven into the fabric of existence, a law not invented by man, but inscribed into the very bones of the cosmos, whispering of an order that was at once mathematical and divine. His invention of calculus, that strange and subtle language of infinitesimals, allowed him to describe motion and change with a precision that bordered on the supernatural, as though time and infinity themselves had become pliable under his hand. And when he bent light through prisms to reveal its hidden spectrum, he shattered the ancient belief in pure, indivisible whiteness, exposing instead a rainbow imprisoned within every being, a reminder that nature's apparent simplicity conceals inexhaustible depths of complexity. Yet to think of Newton only as the cold and austere mathematician would be to mistake the surface for the essence, for behind the published works lay a vast ocean of manuscripts filled with arcane symbols, alchemical recipes, and biblical calculations, secret writings that he never shared publicly, but which, when discovered after his death, revealed a man searching for truths beyond the boundaries of science, a seeker convinced that hidden beneath Scripture lay codes foretelling the rise and fall of kingdoms, the return of Christ, and the ultimate end of the world. A thinker who believed that metals might be transformed and purified, that matter itself concealed secrets of divine fire, and that the universe was not only governed by law, but infused with mystery. How strange it is that the same hand which drafted the Principia Mathematica, perhaps the most rigorous scientific text ever composed, also scribbled in restless nights about the Philosopher's Stone, the Temple of Solomon, and the secrets of revelation. How uncanny that the same mind that disciplined the motion of the planets also searched for God's hidden calendar in the books of Daniel and Revelation. How unsettling that the father of modern science lived in a world not yet separated into rational and mystical domains, but rather one where mathematics, magic, theology, and natural philosophy coexisted as interlocking pathways toward hidden truth. And what if, we must ask, Newton's unparalleled breakthroughs in physics and mathematics were not achieved in spite of his mystical pursuits, but because of them, nourished by his willingness to enter into realms of thought where ordinary minds dared not wander, guided by a conviction that the visible world was a veil concealing a deeper reality. For Newton's genius seems less like the tidy outcome of reason alone, and more like an uncanny convergence of discipline, obsession, and vision, a fusion of logic and mystery that allowed him to glimpse what others could not: invisible forces binding the cosmos, infinite processes shaping time, hidden colors lurking within light. He was, after all, a man plagued by jealousies, rivalries, and suspicions, feuding bitterly with Robert Hooke, clashing with Leibniz in the infamous calculus dispute, battling John Flamsteed the astronomer over access to data, his temperament often as stormy as the heavens he charted, as though genius carried within it a destructive fire, consuming even as it illuminated. And yet, despite these flaws, his work reshaped human destiny, for the Principia gave birth to celestial mechanics, enabling voyages across oceans and into space. Calculus became the universal tool of science, engineering, and economics. Optics laid the foundation for discoveries that would eventually lead to lasers, fiber optics, and quantum theory. And still, one cannot escape the sense that Newton's discoveries, though monumental, were fragments of a larger mystery he never fully disclosed: that gravity, that most fundamental of forces, remains inexplicable in its essence, for even Newton admitted he could not describe its cause, only its effects, confessing, hypotheses non fingo, I frame no hypotheses, leaving gravity itself as a kind of riddle, an invisible hand whose true nature remained hidden, as if Newton had opened the door to a chamber whose depths stretched further than he dared to walk. In this way, his legacy is both triumphant and unfinished, both radiant with clarity and haunted by shadows, for every answer he gave seems also to conceal a deeper question, every law an invitation to probe the mysteries further. Perhaps that is why Einstein, centuries later, would expand and transform Newton's laws into relativity, bending space and time themselves, and why modern physics still wrestles with forces Newton hinted at but never explained, as though the old magician left behind clues scattered in plain sight, awaiting minds bold enough to follow. And so, Newton endures not merely as a great scientist, but as an enigmatic figure whose life resists reduction, a man who balanced the scales of the mint while dreaming of apocalypse, who defined motion while searching for divine rest, who revealed light's spectrum while probing darkness for hidden wisdom, who stood at the threshold of reason and mystery, forever reminding us that the universe may be governed by laws, but those laws are written in a language that still feels half mathematical, half mystical, a code glimpsed but never wholly deciphered, a reminder that knowledge itself is both illumination and shadow, and that, in the life of Newton, the greatest of thinkers, the human mind touched the edge of eternity, yet remained haunted by the unknowable. And yet, the aura surrounding Newton's legacy is not confined to the neat boundaries of mathematics and optics, nor even to the political and institutional roles he filled. It is instead shrouded in a mist of half-forgotten manuscripts, cryptic annotations, and the unsettling sense that the man who gave the world clarity about the falling apple also sought hidden patterns in the rise and fall of kingdoms, in the coded mysteries of Scripture, and in the esoteric language of alchemy. For beneath the polished image of Newton as the rational father of modern science, there lies another Newton, private, obsessive, compelled by the idea that divine truth was scattered like fragments of a shattered mirror across nature, Scripture, and matter itself, and that only a mind of rare genius might collect and reassemble them. This duality has given his story a resonance that defies mere academic cataloging. Some contemporaries whispered that Newton's eyes had seen too much, that his sleepless nights surrounded by crucibles and manuscripts had led him into realms better left unexplored, that in the pursuit of light, he had also wandered into shadow. Others believed that his brilliance was proof of divine favor, that Providence had chosen him as an instrument to reveal truths hidden since the dawn of creation. What is certain is that Newton himself felt his mission extended beyond the mechanics of planets and the optics of prisms. He spent more time writing about theology and biblical prophecy than about physics, though posterity remembers the latter far more vividly. Whole volumes of his work remain veiled in obscurity, filled with interpretations of the book of Daniel and Revelation, in which he sought timelines for the end of days, convinced that the hand of God could be measured just as surely as the orbit of a comet. It is this hidden Newton that makes his legacy more mysterious, for while one Newton gave us the laws of motion, the other Newton searched tirelessly for the lawgiver, nor for the divine architect, whose handwriting he believed was encrypted in both Scripture and the stars. And herein lies the paradox. A man who defined the scientific revolution, whose very name became synonymous with reason and calculation, was at the same time an alchemist poring over recipes for transmutation, and a theologian convinced that corrupted churches concealed ancient truths. His colleagues in the Royal Society may have admired the former Newton, but would have shuddered, or perhaps laughed, had they known the full extent of his nocturnal pursuits. The boundaries between science and mysticism had not yet hardened in his age, but even so, the intensity with which Newton pursued the occult side of knowledge was extraordinary. Some suggest that it was precisely this restless probing into hidden realms that fueled his scientific imagination. The alchemist's vision of hidden essences gave way to the physicist's conviction that unseen forces like gravity bound the cosmos. The theologian's belief in divine order underwrote the mathematician's search for universal laws. Newton himself did not distinguish sharply between these pursuits. Truth was truth, whether revealed in the rainbow or in the apocalypse. Centuries later, scholars would debate whether Newton's esoteric writings were an embarrassment to his reputation or an essential part of it. The discovery of thousands of pages of theological and alchemical manuscripts in the 20th century forced historians to reconsider him not just as the patron saint of reason, but as a figure straddling two worlds: the fading medieval cosmos, with its angels and philosopher's stones, and the emerging modern world of experiment, calculus, and scientific method. That he lived in both worlds simultaneously only deepens the enigma. Perhaps this is why his legacy endures with such intensity. It is not simply the legacy of a man who solved problems, but of a man who embodied the transition between eras, carrying within him both the clarity of modern science and the shadows of ancient mystery. There is, too, the matter of Newton's personality, which adds another layer of intrigue. Accounts describe him as aloof, solitary, suspicious of rivals, prone to jealous quarrels with fellow scientists such as Robert Hooke and John Flamsteed. Yet he could also charm when necessary, winning favor at court and securing positions of influence. His coldness was not merely temperament, it seemed to serve as armor for a mind absorbed in inner battles. The disputes he waged with Leibniz over calculus, or with Flamsteed over astronomical data, were not mere academic disagreements. They took on the character of vendettas, as if Newton felt that cosmic truths were being stolen or distorted, and that he alone was their rightful guardian. In this possessiveness lies a kind of dark grandeur. Newton did not see knowledge as a communal project, but as a sacred trust, jealously guarded. To cross him was to risk obliteration, for his pen was as sharp as his intellect, and his capacity for sustained animosity could be as relentless as gravity itself. Yet despite this harshness, or perhaps because of it, his authority became unassailable, his figure looming over the scientific community like a monarch enthroned. When we consider the arc of his life, it is tempting to imagine Newton as a solitary prophet of reason, standing apart from his age. But in truth, he was deeply embedded in the currents of his time, currents of political upheaval, religious anxiety, and intellectual ferment. He lived through the English Civil War's aftermath, the Restoration, the Glorious Revolution, and the rise of the Enlightenment. Each of these upheavals left their imprint upon him. The political instability of his youth may have driven him toward the certainty of mathematics. The religious disputes of his age may have drawn him into the labyrinth of prophecy. The scientific rivalries of his century may have sharpened his jealous vigilance. This, his legacy, cannot be disentangled from the broader story of 17th and 18th century Europe. He was both a product of his time and its transcendent figure, both a participant in its quarrels and the architect of ideas that outlived them. Even his death in 1727 did not silence the aura of mystery. Buried with honors in Westminster Abbey, Newton was celebrated as England's greatest son, a national treasure whose genius had illuminated the world. Yet whispers remained of the other Newton, the secretive alchemist, the solitary theologian, the man who may have known more than he dared to reveal. Over the centuries, statues and portraits have frozen him into a symbol of reason, but his manuscripts tell a different tale, of a restless seeker who believed that nature and scripture alike were veils concealing divine truth. To engage with Newton's legacy is therefore to confront a double image, the public Newton, master of laws, and the private Newton, explorer of mysteries. Between them lies the shadow that gives his legacy its haunting power. And so the enigma of Newton deepened with every retelling, as though his figure had become less a man of flesh and more a spectral presence moving through history, whispering equations and prophecies with equal gravity, unsettling those who tried to contain him within the neat category of scientist. For the truth is that Newton himself would never have accepted such a narrow label. For in his eyes, science, theology, alchemy, and philosophy were all threads of the same divine tapestry, and to pull at one was inevitably to tug upon the others. What if, he seemed to ask, the same hand that curved the planets in their orbits had also inscribed the secret patterns of prophecy in sacred scripture? What if the mysterious attraction of masses across empty space was but a reflection of an even greater attraction, the pull of human souls toward their creator? His contemporaries might not have framed the questions in these terms, but Newton's own private notes suggest he saw little distinction between them. In the margins of his scientific notebooks are scribbles about biblical chronology. In his alchemical papers are metaphors that echo his optical theories. He moved seamlessly between prisms and prophecies, as though both belonged to the same laboratory of the divine. This seamlessness is what unsettles modern readers, trained to separate science from superstition, physics from faith. Yet to dismiss Newton's mysticism as mere folly is to misunderstand the fire that drove him. He was not content to be a mechanic of equations. He wanted to be a seer of truth. Every falling apple, every flicker of refracted light, every rumor of ancient wisdom became for him a clue in a cosmic puzzle. To solve it required patience, solitude, and a willingness to defy convention. Perhaps this is why Newton often seemed so cold to those around him. His affections, his loyalties, his very humanity seemed sacrificed to an invisible quest. It is as though he lived half in this world and half in another, perceiving threads of order that others could not. There are those who argue that Newton's obsessive secrecy was itself a symptom of this double life. He published only when forced, withheld results for decades, and shrouded his private studies in code and cipher. Some attribute this to paranoia, others to perfectionism, but there is another possibility. What if Newton feared that unveiling certain truths would be dangerous, that knowledge once loosed could not be controlled? Consider that his law of universal gravitation, which today feels benign, was in his time a shocking revelation, a force acting invisibly across emptiness, binding the cosmos without need of angels or crystal spheres. Might he have feared that his theological and alchemical insights, if revealed, would provoke scandal or upheaval? Might he have believed that some truths were meant only for the initiated? If so, his silence was less cowardice than guardianship, an attempt to control the timing of revelation. In this sense, Newton resembles not just a scientist, but an oracle, one who dispenses knowledge sparingly, aware that the wrong disclosure at the wrong time can destroy. The irony, of course, is that posterity chose to sanctify the Newton of equations while burying the Newton of mysteries. Schools teach his laws of motion, but not his interpretations of revelation. Physics texts celebrate his calculus, but not his search for the philosopher's stone. And yet, as more of his manuscripts come to light, the hidden Newton emerges like a ghost returning to claim his place. Modern readers are forced to reckon with the possibility that his scientific genius and his mystical obsessions were not separate, but intertwined. Perhaps the vision of a universe held together by invisible forces was born not from laboratory precision alone, but from the alchemist's dream of hidden essences. Perhaps the confidence that nature obeys laws came not only from experiment, but from a theological conviction that a rational God had inscribed order into creation. In this sense, the Newton of gravity and the Newton of prophecy are one and the same, two faces of a mind too vast to be confined. His legacy, then, is not just a set of discoveries, but a challenge to see whether we dare hold together what he held together, to accept that reason and mystery may not be opposites, but companions. This is why Newton's story continues to inspire not only scientists, but poets, not only rationalists, but seekers. He stands at the borderlands, a figure of light and shadow, reason and revelation. To invoke his name is to invoke the possibility that human thought can pierce the veil of the cosmos, but also the warning that such piercing may uncover truths both wondrous and unsettling. And so his shadow stretches across centuries, a reminder that the foundations of modernity were laid not by a man free of mystery, but by a man consumed by it. Even now, in the 21st century, when satellites confirm his equations and particle colliders extend his mechanics, the aura of Newton remains more than scientific. One feels, reading his words, that he still guards secrets, that the full measure of his vision has yet to be grasped. Perhaps there are insights in his cryptic manuscripts that await deciphering. Perhaps there are warnings concealed within his prophecies. Perhaps the very elegance of his mathematics conceals a deeper harmony still undiscovered. The thought lingers like a half-heard echo. What did Newton know that we have forgotten? What patterns did he glimpse in the fabric of reality that remain invisible to us? Such questions haunt his legacy, ensuring that his figure is never reduced to a mere portrait in a textbook. It is in this haunting possibility that Newton glimpsed more than he revealed, that his legacy acquires the shimmer of myth. For though we can measure his equations with extraordinary precision, we cannot so easily measure the depth of his vision, nor the darkness of the silences he kept. Was his secrecy simply the armor of a cautious scholar, or was it the shadow of truths too vast and dangerous for his own century to bear? Imagine the candlelit chambers where he worked alone into the night, the flicker of flame upon pages filled with symbols and diagrams, the smell of mercury heavy in the air as he transmuted metals and ideas alike. There, in the solitude of study, he was less a man of Cambridge and Parliament than a solitary initiate into mysteries stretching back through the labyrinth of time. Every manuscript he touched seems to hum with this tension, mathematics etched with almost divine clarity, alongside cryptic passages about hidden codes in scripture, planetary tables calculated to perfection next to predictions of apocalypse. Who among us would dare to claim we have grasped it all? And yet the world, desperate for certainty, prefers to divide him. Newton the scientist, Newton the mystic. But divisions are always simplifications, and simplifications always distort. Perhaps the true Newton lies in the refusal of division, in the recognition that his power sprang from a mind unafraid to embrace opposites. He dared to believe that the material and the spiritual were not enemies but reflections, that nature's laws and scripture's prophecies were not contradictory but parallel revelations. In such a vision, gravity itself was not merely a mechanical pull, but a whisper of unity, a sign that the cosmos was bound together by unseen harmonies. To accept this, Newton, is to accept discomfort, for it means that science may not be the cold and clinical enterprise we imagine, but something stranger, something more akin to alchemy, a search for hidden structures guided not only by logic, but by intuition, by dreams, by whispers of the infinite. The enigma intensifies when we consider how posterity has mythologized him. In portraits, he appears severe, almost stern, the very image of rational authority. But read the testimonies of those who knew him, and another picture emerges. A man prone to sudden silences, abrupt rages, and uncanny bursts of inspiration. At times he seemed human enough, eating, conversing, even laughing. But at other times he appeared remote, as though listening to a voice no one else could hear. Could it be that Newton lived perpetually between worlds, anchored just enough to leave us his laws of motion, yet drifting enough to pursue mysteries we still hesitate to name? One imagines him walking through the gardens of Trinity College at dawn, the grass damp with dew, his eyes distant, perceiving in the arc of a bird's flight, or the fall of a leaf, not the ordinary play of nature, but the secret language of the universe. It is tempting, of course, to relegate this aura of mystery to legend, to insist that Newton was nothing more than an exceptional mathematician who happened to live in a superstitious age. Yet such dismissals miss the point. Legends endure precisely because they speak to something real, something irreducible in the figure they surround. Newton's contemporaries felt it, his rivals feared it, his admirers revered it. The sense that he saw further than ordinary men, that he stood closer to the fire of creation than most would dare approach. Even now, when satellites trace planetary paths with machine precision, we feel that same awe in the simplicity of his laws, in the elegance of the idea that one principle could govern both falling apples and the dance of the heavens. It is the elegance of revelation, not just calculation, and it carries with it the thrill of mystery. Nor has time diminished the aura. If anything, modern physics, far from displacing Newton, has deepened the enigma. Einstein himself, who expanded and revised Newton's framework, spoke of standing on Newton's shoulders with both reverence and humility, as though aware that the man he corrected still towered in ways unmeasurable. Quantum mechanics, relativity, cosmology, each has complicated the universe Newton described, but none has erased the fundamental insight that order exists, that laws govern, that the cosmos is intelligible. And here the mystery sharpens. For in declaring the universe lawful, did Newton not also declare it legible, as though written in a language humans could learn to read? Was this not itself an act of faith, a metaphysical gamble disguised as science? And if so, what compelled him to such faith but the conviction that the author of the cosmos was rational, purposeful, divine? In this way, Newton's legacy is not only scientific but spiritual. His equations live on in satellites and smartphones, but his deeper influence may lie in the conviction, so ingrained now we scarcely notice it, that the universe makes sense, that it is bound by patterns waiting to be discovered. This conviction has fueled centuries of discovery, yet it is not self-evident. It is an inheritance passed down from a man who glimpsed order where others saw chaos. That he glimpsed it through prisms and prophecies alike only makes the inheritance richer, stranger, more human. For if Newton could hold together the rational and the mystical, might we not learn to do the same? Might the deepest truths require both microscope and metaphor, both equation and myth? And so the question remains, who was Isaac Newton, truly? A genius, yes, but also a guardian of secrets, a wanderer between worlds. His discoveries transformed the modern age, but his silences suggest vistas still unexplored. In every apple that falls, in every orbit traced by a planet, in every spectrum split by a prism, we glimpse his presence. And yet, in every coded manuscript, in every cryptic note, we sense what has been withheld. Perhaps this is why his legacy feels inexhaustible, because it is incomplete, because he left behind not only answers but mysteries, beckoning us onward. Newton's shadow stretches not just across physics, but across imagination itself, reminding us that the boundary between knowledge and wonder is never fixed, that the pursuit of truth is always tinged with the unknown. And so, to linger on Newton is to linger on the threshold between certainty and enigma, for his life reminds us that knowledge is never final, that every revelation casts new shadows, and that even the most brilliant minds remain haunted by questions no theorem can resolve. In the centuries since his death, countless scholars have pored over his published works, dissecting the laws of motion and the theory of universal gravitation. Yet just as many have been drawn irresistibly to the vast archives of unpublished manuscripts, scribbled notes on alchemy, cryptic timelines of apocalyptic prophecy, diagrams that blur the line between chemistry and mysticism. To turn those pages is to feel the chill of unfinished business, to sense that Newton's mind roamed corridors we have scarcely dared to enter. And perhaps this is the truest measure of his genius. Not that he explained everything, but that he left behind mysteries that still compel us to search. In this way, Newton becomes less a figure of the past than a living presence, a guide whose shadow beckons us toward horizons where science, philosophy, and myth converge. One imagines him watching, not with the cold detachment of a scholar secure in his conclusions, but with the burning curiosity of one who knows that every answer opens into deeper riddles. Consider the paradox of his reputation. To the public, Newton is the very symbol of clarity and order, the man who banished superstition with mathematics and revealed the mechanical elegance of the cosmos. Yet to those who probe his private writings, he appears almost the opposite. A seeker entangled in esoteric traditions, a man convinced that hidden forces govern the material world, a mind captivated not only by the rational but by the occult. Can both portraits be true, or are they but fragments of a single, more complex reality? The reality of a mind that understood the limits of categories, that saw no contradiction in pursuing calculus by day and transmutation by night. To dwell on this paradox is to realize that the neat narrative of science marching toward progress is itself an illusion, a simplification that conceals the turbulence from which insight arises. Newton's greatness lies precisely in this turbulence, in his willingness to traverse it, in his refusal to settle for half-truths. And yet, the mystery deepens further when we recall how reluctant Newton was to reveal himself. Unlike modern figures who court fame, Newton guarded his solitude with fierce vigilance. He delayed publication, concealed his methods, and recoiled from controversy. Yet when forced into it, he fought with ruthless brilliance. What was he protecting? Was it simply the caution of a man wary of critics, or was it the instinct of one who sensed that full disclosure might unsettle the foundations of his age? Perhaps both. His discoveries reshaped the world, but his silences remind us that even he recognized truths too strange, too dangerous, or too incomplete to unveil. And so the legend persists. Newton as both revealer and keeper of secrets, both architect of modern science and guardian of ancient mysteries. This duality is no accident. It is the essence of his power. What then are we to make of his legacy today? We live in an age saturated with data, brimming with technologies Newton could scarcely have imagined, yet his shadow looms as large as ever. Satellites obey his laws as they orbit the Earth. Spacecraft navigate the solar system guided by equations he penned centuries ago. But beyond these practical triumphs lies something less tangible yet more profound. The sense that the universe is knowable, that behind appearances lies order, that the human mind can touch the infinite through reason. This conviction, inherited from Newton, continues to shape every scientific endeavor, every philosophical inquiry, every act of imagination that dares to seek coherence in the chaos of experience. And yet, alongside this conviction lingers the echo of his other pursuit, the search for hidden meanings, for divine patterns, for the ultimate harmony that fuses science and spirit. Perhaps it is here that Newton speaks most urgently to us now, in an age where knowledge expands but meaning often recedes. He reminds us that discovery without wonder is hollow, that truth without mystery is brittle, that the quest for understanding must embrace both clarity and awe. In the end, Newton's life is less a completed story than an unfinished invitation. His laws endure, precise and powerful, but his silences beckon us toward questions still unanswered. What is the nature of the force we call gravity? Why does mathematics map reality with such uncanny accuracy? Is the universe purely mechanical, or does it hum with purposes we cannot yet discern? These questions, unresolvable yet irresistible, are Newton's true legacy. For in leaving us both answers and enigmas, he ensured that our pursuit of knowledge would never stagnate, that we would forever stand as he did between the visible and the invisible, the measurable and the ineffable. And so we continue, guided by his equations, yet haunted by his mysteries, compelled by the same restless spirit that drove him to peer beyond the veil of appearances. Isaac Newton remains with us not merely as a historical figure, but as a presence woven into the very fabric of inquiry itself, a reminder that the universe is stranger, vaster, and more mysterious than even the greatest genius could fully unveil, and that our task is not only to measure it, but to marvel at it, to chase its secrets even as they recede into the infinite horizon.